All right, so today we are beginning functions. And before we can talk about what a function is, we need to talk about what a relation is. All right, so it says a relation is a correspondence between two sets. So here's a couple other ways to write that. We can say X corresponds to Y. We can say Y depends on X. We can use this little arrow symbol, which means maps onto. So what's a mapping? Let's draw a mapping. Mapping is where you use arrows and you correspond elements from one set to elements of another set. So let's say we have this set with -2 and 4 and 5 in it. And then we have this different set with elements of 3 and 6 in it. So the mapping is saying, what does -2 correspond to? I want everything on this left set to correspond to something on the right set. So for example, let's say -2 corresponds to 3. Let's say 4 corresponds to 6. And let's say that 5 also corresponds to 6. So sometimes you'll have the same x's correspond to a y or two different y's corresponding to an x. And we're going to talk about the difference, okay? So remember from Algebra 1, which variable do we use as our independent and which variable do we use as our dependent? Raise your hand if you got the answer to that. Aiden? I didn't say last name, so it's okay.
The x is the dependent. No. Independent. The y is
Okay, there you go. So x is the independent or the input. Y is the dependent or the output. Okay, you get a shot for that. Okay, that's 0 points. Good try, though. Good try.
Wait, so I have to throw it all the way from right here?
You can get up and move if you want, but you gotta be snappy about it. Okay, now what is a function? First of all, it says let x and y be two non-empty sets. You can't have a set with nothing in it. You have to have something in your set, so it's not empty. Non-empty. A function from x to y is a relation that assigns to each element in x exactly one element in y. What does that mean? Well, let's draw a visual of this. So I'm going to give you an example of a function and something that's not a function. So this mapping, let's call that first set x. Let's call this set y. Let's say x has -5, -1, 4, and 9 in it. And y has -8, +8, and -2 in it. So we're going to map elements from x onto elements on y. Let's say that -5 maps to -2. -1 is going to map to -8. 4 is going to map to 8. And 9 is going to map to -8. So this is a function. This is a function. So what it's saying is that each element in x will map onto or correspond to exactly one element in y, right? So look, each element here, -5 goes to one y value, -1 goes to one y value, 4 goes to 8, 9 goes to -8. Now notice that two of these x's are going to the same y. That's okay. As long as each of these x's only goes to one y, you have a function. Yes?
You said his name was recorded.
I know, but I have a lot of students named Christian, Matthew, Sarah, Mary. Like, honestly, that's not personally identifiable information. PII. You have to have an ID number and a last name for it to be PII. But I did mess up. I'll say student. Can I call you LeBron? Sure, LeBron. Okay. Here's an example of not a function.
Oh, Lord.
Not a function. Maybe I'll just make up names for you guys.
Can I be Zimbabwe?
Sure, Zimbabwe. Negative 5, 4 is my set of x's. Can you be what? Is that like a gamer name? Negative 8, 8, and negative 2. Those are your y values.
Ooh, can I be Joe Mama?
No. You could be Joe, but not Joe Mama. Alright, negative 5 is going to map to negative 8. It's going to map to negative 2, and 4 is going to map to 8. Okay, to shoot the ball, can someone raise their hand and tell me why this is not a function?
It's like the vertical line test, like if it goes down the same x value twice, it's not a function.
We're going to talk about that when we start looking at graphs of functions, but can you tell me from this mapping how we know it's not a function?
Because x has 2 y's.
This student.
One x goes to 2 y.
There you go. Okay, specifically negative 5 can't map to 2 different y values. So this is the reason right here. This is the reason that it's not a function, right? Okay. Now, there's different ways to tell. If you're looking at a mapping, we just want to see if there's 2 arrows coming out of one x value. That makes it not a function, okay? Oh, yeah, sorry. Sorry, student.
Oh, yeah.
Catch up.
Don't look past the desk. Go ahead. I will tell you it's not about power, it is about finesse.
Kobe, oh my god.
Don't throw it hard. It'll stick better if you don't throw it, because it'll just bounce off the wall if you put too much power on it. Okay? All right. Now you know for next time, student. Okay, so mapping is one way that we can represent a function. Another way that we can represent a function is a set of points, right? A set of points. Let's write that down. Set of points. To throw the ball, can anyone tell me what these symbols are called? Yes? Nope. Braces is correct. I don't think anyone's gotten a point yet, no shoot. Finesse. But you gotta put a little, you gotta get it to the point. Okay. Close enough.
Well, connect it to the table. Is that
That's
count?
gotta be worth a point.
Those are called, no, table is no points. Those are called braces. Alright, so instead of the mapping, I can just give you a set of points, a set of coordinates. Inside each coordinate, of course, the first number is the x and the second number is y. You guys are used to writing ordered pairs like that, x, y. All right, my question is it a function?
Yes.
Okay, student in the back, why do you say yes?
Because they...
No. You're not student in the back. Student in the back. Okay, what's the fast way to tell?
The x values are the
It's the x values, yeah. Okay, so because I have all my x's are different, then I'm not going to have any x going to 2 different y values. So we're going to write this. The x's do not repeat. So if you see a list of points, you're just seeing, did the x's repeat? No, they don't. So that means each x is going to 1 y value. Here, HC. Can you take it from there?
What do you call it? Oh my god.
Woo!
They almost hit the Prometheus.
It's okay. All right, number B. Is this a function? Yes or no? Raise your hand. I already said your name. Aiden.
No.
I'm over here.
Correct. All right, this is the reason that this is not a function, because negative 3 can't map to both 8 and 9. Let's write x's repeat. Go ahead. Oh, okay.
That's 4.
I'm going to add all the scales points over here. Is it 4?
It's on the line.
It's 3.
No, it's
I'm closer on the line.
I'll take 3.
I'll give you 3. I'm going to give you 3. I'm going to give you 3. Okay.
I'll be correct.
Now, before we move on to that equation, it's okay. Before we move on, I want to give you kind of an analogy that might help you determine quickly if something is a function or not a function, okay? How many birthdays does everybody have?
I have 5.
1. You were born on one day, right? Can you be born on 2 different days?
Yes.
Impossible. No. You're born on one day. Everybody has one birthday, okay? So a function is like a birthday. Every person has exactly one birthday. Now, can 2 people have the same birthday?
Yes.
Yes, that's fine. Still a function. You can have 2 people that have the same birthday. I have the same birthday as my grandfather, right? March 1st is coming up.
Watch
Like all kinds of gift cards to. Okay. But now, is it possible for someone to have more than one birthday? It is not. So that is not a function. You can't have a birthday on January 2nd and on February 4th. So you can think about birthdays like functions.
And Y is birthday.
The X is the people and the Y is the birthday. Yep. Okay, now, number C, X equals Y squared. I want everyone to draw a picture of this. The first person who has the correct picture gets to throw the ball. X equals Y squared.
Alright, let me whip out my Desmos.
Nope. You need to know what that looks like.
I know what it is.
Right, draw it down and raise your hand. The first person who has the correct picture. Nope.
I did it. No, I did it. I think I'm wrong. I'm scared.
Nope. But try. Nope. Raise your hand if you think you have the picture.
Oh, I got it.
Nope. What is
Isn't it
that?
like
This.
X equals Y squared. Yes. Okay. Describe what you drew to everybody.
What?
Describe what you drew using mathematical terms.
It's a parabola, but facing this way instead
a
of that
sideways
way.
parabola?
Why is
Correct.
it sideways?
It is a parabola that is sideways and is opening to the right. Here, student.
Come on, you like
Come on, LeBron.
Don't miss. Oh my God.
Put
This
it
is
in
like.
your 6.
Oh!
I'm
You're
gonna give you
actually wrong.
6 for that.
Alright, Paul George. Why do you do
Okay, man, you got 6. Okay.
Can
LeBron
you
just
beat- what's
got a
that man's
6-pointer.
name?
All right, let's draw the picture
I'm just-
that LeBron drew. All
Esther?
Can you be Esther?
right,
Is it
so
Esther though?
let's talk about this. What is this the picture of? This one, look, this parabola opening up is y equals x squared. But if I reflect it across the line y equals x, now it looks like x equals y squared. This is the inverse, okay? Now, it's not enough to just say the square root because that's just half of this function, but it is the parabola. Now, is this a function, yes or no? No. How can you tell from this? Okay, what do you mean by that? Vertical line test.
If it passes through 2 points, it's not a function.
Be less specific.
It passes through 2
It
y.
passes 2
It hits 2 y.
It hits the X
multiple.
It's the y-axis.
Say it again. If a vertical line touches a function more than once, doesn't have to be 2, it could be 1,000,000. If it touches a function more than once at a time, then it is not a function. Because look, this x value has 2 different y values, right? It's got a y value up here, and this x has a y value down here. What do we call this test? Vertical line test. Okay, let's write that down. Fails the vertical line test. Vertical line test. I'm going to let 2 of you throw.
Can I have LeBron throw for me?
You throw, and then I'm going to let him throw. Come on. Okay.
That word is rigged.
It's about the finesse.
Oh,
Finesse.
Okay.
All right.
It's not rigged.
It looks like
It's
the
on
whole
the line.
You're right.
That's on the
It
line.
looks
Okay.
like Neptune.
All right.
Why do people prey on my downfall?
We love you, Evan.
It's like a 1.5.
Why?
It's okay.
Just confess your love?
She's probably preying on my downfall too.
All right. So if you can visualize a picture of what your relation looks like, you can use the vertical line test to tell if your relation is a function or not, and this one is not. Okay. So moving on. Now we're going to evaluate functions. Can anyone raise their hand and tell me what does f of 3 mean? Not what does it equal, what does it mean? See.
I don't know if that's the answer to the question.
So that's what you would do. So you're on the right track, but I want to know, what does f of 3 mean? Give it a try, V. That's not what f of 3 means, but thank you for trying. Anybody else? E?
Function of 3?
What is that? But what does that mean?
What is that?
I don't know.
Function of 3.
I tried. X is 3.
Jay? Okay, yes, x is 3, but that doesn't tell me what this is. H?
The vertical line on 3 and the x-axis.
No.
Can I have a hint for 3,000?
Okay, well, if you can't tell me what it means, what do I do? Tell me what to do. How do I calculate f of 3? See.
Because 3 is going to get 3.
Into what?
Like you do 2 parentheses, or into the given function.
Okay, so you have a given function. You're plugging 3 in for
X.
the x, and you're going to get a number, right? You're going to get an answer. What is that answer? It's the what? Y equals what?
Y equals 3.
It's not necessarily the y-intercept.
Y equals f of x.
Y'all are overthinking it.
F of x.
3. X is what it is. 2.
What?
Y equals.
Another hint, another hint, another hint.
We're like dancing around it, guys. It's just the y value on the function where x is 3. It's what
Have we
the
not said that correctly?
no, it's the no. You guys are saying like vertical lines and what? It's the y value on the function when x equals 3, right? It's what is the value of the function when x equals 3?
I don't know anymore.
Okay, so 3 is an x, that's the input, and you plug it into your function and you get an output. That output is a y value, so f of 3 is the y value on the function where the x is 3. That's the gist of what we're trying to say. Okay, now how do I calculate f of 3? This student over here said everywhere that you see an x, so I have this quadratic function, we're going to substitute in a 3. So that's 2 times 3 squared minus 3 times 3 plus 4. Raise your hand when you have the answer. Yes.
13?
Ooh, you didn't raise your hand. All right, I'm going to give it to Mama E right here. Where is the ball?
He needs a chance to redeem himself.
Okay.
It's like bowling. Okay,
Okay,
I'm going to give you two for that one. Okay, you're catching up to LeBron.
Ho, ho.
All right, you guys remember order of operations? We do the exponents first. So 3 squared is 9. 9 times 2 is 18. 3 times 3 is 9. So that's 9 plus 4 is 13.
14.
Okay? All right, next question. When your input is a number, your output is a what?
Number.
A number, okay? Input is a number, output is a number. You get out what you put in. How many times have you been told that, right? What if your input has an x in it? What would your output look like?
Function.
No, not. I mean, yes, but what is it going to look like? What? Something with an x. There's a word.
Purpose squared.
That one. That's what I'm looking for. Say it again. An expression. So it's going to be an expression. When your input has an x in it, your output is going to be an expression of x. Okay? Give it a try. Give it a try. Give it a little hook.
Like move closer.
Ah! What are we calling that?
0.
Okay.
Oh my God.
That's a what. That's a what.
On the board.
He's mad.
Anywhere on the board is a point. Yeah.
Damn it.
Okay. So, whatever you put in, you get out. If your input is a number, your output is a number. If your input is a variable, your output will be an expression using that same variable. So let's try this. Everywhere you see an x, in parentheses, you're plugging in a negative x. 2 times negative x, quantity squared, minus 3 times negative x plus 4. Again, we're doing our order of operations, whether you learned PEMDAS or GEMMA. GEMMA is new to me, but parenthesis, exponent, multiply, divide, add, subtract. GEMMA stands for grouping, exponent, multiplicatives, and additives. All right, so what do we get?
Oh, heartburn.
What's negative x squared?
2x.
What's negative? Let's just start with that. What's negative x squared? X squared.
Yeah.
What? You're negative x times negative x is a positive x squared, right? So that's going to be 2x squared. Negative 3 times negative x is plus 3x plus 4. So, while you were right, yes, that is a function. I was trying to say that you get an expression with x in it. Okay? All right, this one. What does this mean?
You change all of the signs to negative or something like that.
Yes, that is true. I'm going to let you shoot for that. You change all of the signs, and what does that give you?
Inverse function.
Not the inverse.
Opposite function.
The opposite. Okay, you shoot and then you shoot. It gives you the opposite. Yeah, but you gotta go fast. You get 5 seconds.
Run it.
Let's see your hustle. 5,
Send the flick of the
4,
wrist, man.
3, 2, 1. All right, point. That is a point.
I got a point.
That didn't hurt me.
All right.
That's what you're confused
Give it to A.
Catch out, A. I'm A.
Okay. Verdi said it's to you. That's no points. Okay.
I wasn't sure.
All right, so this means the opposite, which means that we're just going to change the sign of every term in the equation. The word for that is negate. We are going to negate every term. That means change the sign. So negative 2x squared plus 3x minus 4. Okay, that's an important skill because we're going to use that tomorrow to prove what kind of symmetry that a function has. Next, f of x plus f of x.
You add two functions. Add the function to minus.
How do you add a function to itself?
Multiply. Combine my functions.
That's the one. We're going to combine like terms. So we've done this year. I'll let you shoot. I'll let you shoot for that, E. Okay, we're going to combine like terms. Effectively, this is the same as doing what? I heard someone say it. It's like multiplying the whole function times 2. So you could either double every term, or you can combine your like terms, and we get 4x squared minus 6x plus 8. All right. Here, get your shot. Shoot your shot.
Oh my
Why
god.
don't you just sit right there? If you're going to keep shooting.
That's a good point. I just wanted to keep making fun of it.
Okay, go. All right. That's a point. Catching up. Catching up. All right.
He is all I need. Oh, for real?
All right. This one is the hardest one yet. What is f of 1 plus 2n? Now I'm switching letters on you. It doesn't matter. Whatever letter you plug in, you should get the same letter as your output. When we get to big boy math and big boy physics, we use all of the letters. We don't just use x and y. We use x, y, z, v, u, t. We use theta. We use ABC. All the letters. Yeah. So we got to get used to seeing different letters other than x. Everywhere you see an x, you're plugging in a 1 plus 2n. The first person to show me their answer gets to throw. Actually, everyone who shows me a correct answer gets to throw.
What?
Did you solve it?
Yeah. Simplify your answer.
Do we gotta put in?
What?
Do we have to put... No, you may not. I just said you got to be able to use different letters. Your answer should have n in it. So first you're going to square. Then you're going to multiply. Then you're going to add. Just raise your hand when you think you have the simplified answer. should have n's in it. You got it? Okay. You're gonna square it out, multiply it out, combine like terms. Where's your answer? Nope.
What? How?
It should have an n squared in it.
What?
What?
Oh.
What?
No.
What? Nope, you didn't square this right. When you square a binomial, you should get 3 terms.
Hey, this come back.
Oh,
Your middle term is incorrect.
Yeah, I'm done.
Did anybody get it correct? Did it just fall?
Yeah. No, today, no.
Is this done?
Well, your answer is
That three
written
times?
backwards. It is
Yes.
correct. You get to shoot.
Oh,
I'm
yeah.
still looking for
Okay,
answers.
okay.
Still looking for
No, it's not.
answers. Your middle term is incorrect. What did you get? None of your terms are correct.
What?
If I'm wrong, I'm gonna start creating another book.
Your first term is correct. I double dog dare. Your second 2 terms are not correct. Go
Oh, I
ahead and go
didn't
shoot.
do Which term is it correct? I didn't distribute. Which
Yeah.
term is it correct?
Your middle term is not correct. Your second 2 terms were not correct.
I want to see something different. Hold on.
Go ahead and shoot, Jay.
Oh crap.
What are we looking at?
The second one.
Yes, you can shoot too. Still up for grabs. Still up for grabs. Okay. He's going 1 point at a time. He's playing the slow burn.
How's that wrong? I don't know. How's this wrong? I don't know. There's nothing?
Oh, I can show you my.
At least I'm not last.
Let me show you my next step.
Wait.
Miss.
I'm not showing the answer. I just want to show you the next step to make sure everybody's on the right track. The first thing I'm going to do is I'm going to square this. Let's talk about this. What's 1 times 1? 1. What's 1 times 2n?
Huh?
What's 1 times 2n? 2n. What's 2n times 1? Also 2n. So you have 4n now. What's 2n times 2n? That's 4n squared. So this step is the most important one. You have to be able to square a binomial and get the 3 terms. Okay? Now this negative 3 is going to get distributed. So that becomes a minus 3 minus the 6n plus 4. Then I'm going to distribute the 2. So I'll let you finish that. Still taking answers. That's correct. You can throw. What you got? Ooh, your middle term is correct. The other 2 terms are not correct. Sorry, H. Yes. All right, you get to throw too. Yes, that is correct. You get to throw 2. Did you get a point? How many points is that?
I saw 2.
-5.
2. Okay, I'll give you 2. Who else is throwing? You're throwing.
Oh, hit road.
Who got it? H, you got 2.
Oh my god.
Man, way to go.
That's a air ball.
Who else gets to throw?
Nothing but net.
Did you get it? Did you make one?
No.
Okay. Here, Art. You can move over here if you want.
Nothing but air.
That's why.
Hit a 6. Hit a 6.
Give it a shot.
Are you not taking any more?
I'm not taking any more right now. That's a 4. Okay.
See, only hit 6 if gravity wasn't
All right.
Answer down
Don't
there.
worry. There's more opportunities. Let's go over the answer. All right. So then when I distribute this 2, I get 2 times 1. 2 times 4n is 8n. This is 8n squared minus 3 minus 6n plus 4. And then at the end, you're combining your like terms. How many n squareds do I have? 8.
No, one thing that says n squared.
How many n's do I have? I know what you meant. There's one term with n squared, but I was looking for the coefficient.
Yeah.
8 minus 6. That's a plus 2n. 2 minus 3 plus 4. That's a plus 3. So that's what we get for that one. Okay? Turn the page. All right, same function. We're going to go, and they're going to get a little bit trickier. F of 2x. F of 2x. Everywhere you see an x, you're plugging in a 2x. Please use parentheses every time you substitute. So 2 times 2x squared minus 3 times 2x plus 4. Evaluating functions is also very important for calculus. So first you square it. That's 4x squared. Distribute. Minus 6x. Plus 4. Final answer. 8x squared minus 6x plus 4. Okay, don't worry, we will have opportunities. We gotta keep moving. All right, raise your hand if you can tell me what is f of a. Just raise your hand if you can tell me what is f of a. LeBron.
Is just f of x wrote a different letter in it?
With an a.
Yeah.
Okay, so what is f of a?
Just f of a. Just, I don't. The equation?
Any other students can tell me what is f of a?
Basically, that equation with all the
Can someone raise their hand and tell me what f of a equals? LeBron.
That, but everything is
Stop saying just read it out. Just read it out.
2a squared minus 3a plus 4.
Thank you. Like every word, yes, you're doing the right thing. That's what you do, but I needed you to just read it to me. So everywhere you see the x, we're just switching that to an a. That's all that is, right? 2a squared minus 3a plus 4. We're literally just changing the variable to a different letter. This is a skill you have to be comfortable with. Again, when we start doing application problems, we use t for time instead of x, and so we got to get used to using any letter. Okay, LeBron, you can throw it.
Oh God.
You're up by 1.
I'm feeling hot right now.
Come on. What do we call that?
That's 2. That's 2. That's 2.
It's closer to 1. That's 2.
Oh my god.
It's on the range.
Oh my
Yeah,
god.
I know, but the average of 1 and 2 is 1.5, so...
2.
I'm gonna give you one.
No.
Okay, let's...
Yes.
1 and a
Round
half.
it up.
1 and a half. All right, this is now the hardest question we've had so far is what is f of a plus h? How many variables do you see? 2. That means in your answer, you should have both a's and h's. I'm going to give you a chance to try this one out. I'm going to set it up with you. So it's 2 times a plus h, close your parentheses, squared, minus 3 times a plus h in parentheses, plus 4. This one is tricky. Raise your hand if you think you have the simplified expression.
Oh, Jesus, take the wheel.
You're missing a term. You're missing the whole term. Yes, supposed to have 6.
6.
Yep, should have 6 terms.
Oh.
Oh my god. Where's the 6th one? Where does that come from?
It's in it.
No.
You probably squared this wrong. If you don't have 6 terms, you probably squared that wrong.
I did it.
Before you raise your hand, you better have 6 terms.
What do you mean by 6
Yes.
times? I don't know.
What count? How many terms?
Oh, I counted it. There's 6.
Yeah.
Okay.
You're correct.
Oh, yay.
Yeah, you got it. Go shoot.
Are you
Hooray!
only taking 1?
Hooray!
No, I'll take anybody who gets it.
Good job.
Yeah, go shoot. Come on, get your shoot on.
If he's too close.
Oh.
Oh my god.
All right, Ari, you try it. Nope.
What?
Anyone else ready?
Call it 2.
For 2. Can I put the A, miss? Can I put 2 on Rosalind? I mean, R, L, whatever.
This is correct. You just shoot.
No, it's 1.5. That's 1.5. That's where Deborah was. I meant LeBron. I meant LeBron. That's where LeBron
How
is.
algebra pays off, you can shoot.
That's 1.5, Ms. Usher.
That's 1.5.
Let's teach her.
That's where LeBron's
You
was.
can say my name, it's my YouTube channel. You're
Miss
correct.
Nelson.
Justice for LeBron.
That's
So
literally
is
where
it two
LeBron was.
or what?
That's correct, you can shoot.
What?
Why are you doing it like
Okay,
that?
that's 1 point. E gets 1 point.
She gets 1.5.
RL got.
RL gets 1.5.
Go ahead,
Hey, we
see.
gonna put 2 for her. F y'all.
My problem is
Wow.
strong with
Good job.
I keep underestimating.
Good job, bro. I'm sorry, I won't let you say anything. What do you want me to call you?
If I told you you can shoot, go shoot. You can go up there and shoot. Get
Can
your
I
points.
shoot again?
Alright, for the rest of you who still have not gotten this, we're going to square this out first. So this is the part, I think, where people make the biggest mistake. A plus h squared is a squared plus 2ah plus
I swear.
h squared. That's a 4.
Really?
Is your name up there?
No.
No. Here's my blue marker. Add yourself up there. So it's a times a plus a times h plus h times a. That's why we have 2 of these middle terms plus h times a. You got to think of that. You're foiling it out, and you should have 3 terms when you're done. Okay? And then
Last one looks a little.
after we square that, now we're going to distribute the 2 and the 3. So 2a squared plus 4ah plus 2h squared minus 3a minus 3h plus 4. Now, none of these terms are like terms. You have a constant, an h term, an a term, an h squared term, an a squared term, and an ah term. They are all different, so we cannot combine any of those together. All right. Now for the pièce de la résistance is I. This is the hardest one. We're going to put some of these together. We are going to take the answer that we just got. We're going to subtract f of a, which is this one. You're going to subtract those 2 functions, and then you're going to divide the whole thing by h. So let's set it up. Here we go.
Write out that whole thing. That's stupid.
It is the difference quotients. Very good. You get to throw for knowing that. You get to throw for knowing that.
Good job.
But you need it for calculus.
I did it earlier today.
We're doing... That's so great that we're doing the same thing in pre-cal and college algebra. You're going to know it so well.
I'll socialize.
Did you get it?
Yeah.
That's 2.
She did
Minus.
All right.
Minus.
I'm going to add,
This is the one.
add your 2. 1, 2.
that.
I hate this game.
Okay, so I'm taking the answer I just got here. I'm subtracting this whole function in terms of a. Notice it's a parentheses because we
Excuse
have to
me.
subtract all the terms. And then we're dividing the whole thing by h. Now, before we divide by h, we have to see if we can simplify the numerator. This minus goes to all 3 of those, right?
Mm-hmm.
Are there any terms that I can combine or that might cancel each other out?
The
2a.
a squares.
2a squared.
The 2a squareds, bye. The 3a's, adios.
Hasta luego.
And the 4's, see ya.
Ah, oh.
Tell me what's left.
4a.
4ah
Plus 2h.
2h squared minus 3h.
Oh my god.
Oh, look, what do all 3 of those terms have in them?
An H.
An h. So we can divide this by h. We're simply going to factor an h out of each term.
No, I don't want to. I don't know.
And then this h will now cancel with this h. And your answer is 4a plus 2h minus 3. Now, I told you that your answer would have both a and h in it, which it does. Okay? This is called the difference quotient, if you want to write that down. This is the difference quotient.
Oh.
This is a really important thing that we use in calculus to find slopes, and we take the limit of this, and it tells us what a derivative is. So this is very important to the concept of studying calculus. You have to be able to calculate a difference quotient, because that's how we find a derivative at the beginning of the year. Okay? All right, so the last thing we're going to talk about today is domain and range, but specifically domain. What does domain mean?
All the numbers.
No, what does domain mean? E.
Where x can go in the function.
What do you mean where x can go?
Like all the possible numbers.
Okay, I like that description. Can you add on to that? LeBron.
Where
Can you?
minimum and maximum of your x equals
But you're just talking about two places.
The quantity of x.
the minimum and maximum of x.
That would give you a starting point and ending point, but the domain can be numbers in between, right? You want to
All the
elaborate?
Possible areas of where x can be in the function.
Okay, I mean, that's pretty close. So the domain is all of the x's where the function is defined. All x values where a function is defined. Meaning, whatever number that you can plug into the function and get an output is part of the domain. So the domain is the x. The range is the same thing. The range is all the possible outputs of a function. It's all the y values when you're looking at a graph.
Do I get a shot?
Sure, go take your shot. Okay,
just wanna give
let's
that
look at this.
a-
3x plus 2, what kind of function is that?
A linear.
That's a linear function. What do linear functions look like?
A line.
A straight line. Okay, what are the possible x's that I could plug in?
All real numbers.
Hey, you can't go past the desk.
All real numbers. All real
I got a
numbers.
second
All
for that.
real
Yes, okay, so my domain...
What?
No, you don't get another shot. Nope, you don't get that one.
That's dumb.
Okay, go sit because we don't have very much time left. So because I can plug any number in here for this x, and this line continues forever in both directions, right? That means it's going to cover every single x value that exists. So we say the domain is all reals, or what's another way to write all reals?
Infinite.
Infinity to infinity.
Negative infinity to positive infinity. Okay? I know that it doesn't ask this question, but what is the range of any linear function?
The y. I mean.
It's also all real numbers because it covers every y value on a graph, right? Every y value being output. What kind of function is this? It's a quadratic. Quadratic functions look like parabolas. What's the domain for any parabola that is opening up or down? Also all reals or negative infinity to infinity. Both of these functions are called polynomials. And polynomial functions are defined for all x values, so that means that their domain is all reals or negative infinity to infinity. That would also apply to cubic and quartic and quintic and sextic and septic and octic and nonic and decic and all powers of x, okay? What kind of function is this? It starts with an R.
Radical.
It's a ratio, which makes it a rational function. Now, look at the first commandment. First commandment. It's all the way over here on my board. You see it? Number 1, thou shalt not divide by 0. So if your function is a big fraction, the denominator cannot equal 0.
I remember that.
Denominator cannot equal 0. So we're going to figure out any x's that make the denominator 0. And we'll continue talking about this tomorrow. If you want to practice what we did today, you have odd book problems on your calendar for practice. And we'll continue with our notes tomorrow. Pause this video.